Hello! In this video we're going to look at sets of outcomes. This is something you typically see in the first couple of weeks of Finite Mathematics. I know for example at IU that most teachers teach it in about week 2, week 3. This roughly corresponds to section 1.4 in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson, and the title of that chapter is Sets of Outcomes and Trees. And we're just going to be looking at sets of outcomes. This is a pretty important concept to really get down. You're going to see this a lot on the finals and the midterms. I mean, this is something that you're going to build upon all semester, so it's really important to kind of get comfortable with it. So we're going to do one of the recommended problems that one of the instructors has recommended. It's actually one of my favorite kinds of problems. It's a little tricky, and when you see it, you might think, oh man, how am I going to do this? But honestly, once you know the trick, and there is a fun trick for that, it's not so bad. So let's start by reading the problem, and then we'll go through and we'll find out the important information that we know, and then we'll figure out what we need to know. So let X be the set containing 1, 2, 5, 6, and 9, and let Y be the set containing A, B, C, D, and E. A product code is formed in the following manner. First, two distinct numbers are selected from X at random, in order, and they are used to form a two-digit number. For example, if 2 is selected first, then 9, the two-digit number is 29. If the number is larger than 30, then 3, not necessarily distinct letters, are chosen from Y. If the number is smaller than 30, then 4 distinct letters are chosen from Y. How many codes are possible? Well, at first glance, this might seem like an impossible problem, but it's really not all that bad. So let's go ahead and start out by writing down what we know. Let's see. What did they let us know? Well, first they let us know that X is the set containing 1, 2, 5, 6, and 9. So let's go ahead and write that down. X is the set, right, curly braces, 1, 2, 5, 6, and 9. Okay. And what's Y? Y is the set A, B, C, D, and E. And I think one of the reasons I find this problem kind of fun is that there's actually two different problems in here that you kind of add together. And so I'm going to split them up and try to explain why I split them up the way I did. So first, two distinct numbers are selected from X at random in order, and they are used to form a two-digit number. Okay. For example, if 2 is selected first, then 9, the two-digit number is 29. Well, I think we get that part. If the number is larger than 30. Well, that's pretty interesting. And we're going to skip over that next part of the sentence. We're going to go on to if the number is smaller than 30. So there's your two different problems. If the number is larger than 30 or the number is smaller than 30. So, and our total question is how many codes are possible? Well, let's go ahead and split this up. So we know that they pull out, quote unquote, two distinct numbers in order. So when I hear in order, that tells me that you really can't pull more than one of each kind out. So I like to use what I call the slot method, and I'm going to walk you through that. So we know that the first bit is less than 30, so I'm just keeping this to kind of separate them out. So let's go ahead and do the slot method. We're going to choose two numbers. And if it's greater than 30, what's going to happen? If it's larger than 30, we're going to choose 3 not necessarily distinct letters from Y. Okay, I can kind of buy that. So let's go ahead and continue kind of solving this one. I'm going to change colors real quick so you can kind of see what I'm talking about. So these two right here are from set X. And in order for this number to be larger than 30, there's only a couple options for this bit right here, right? We couldn't have it start with a 1, we couldn't have it start with a 2, like that's not going to make it greater than 30. So, you know, we can kind of ignore those bits, and we can only look at 5, 6, and 9 for this one right here. So that means there are 3 options there. Okay, you know, I think we all kind of buy that, so let's go ahead and we're going to erase this up here, and, you know, let's go ahead and go back to the next slot. So the next slot here you know, if we chose, let's say we chose 5. Well, if I chose 5, then that means I can't choose 5 again, just for an example. So that means that, you know, any other number I chose is going to be greater than 30. Like if I chose 1, that's going to be 51, that's greater than 30. If I chose 2, that's 52, that's greater than 30. So that means there are 4 options for the next part. And this is the case whether we chose 6 or 9. And the way you do that is you start multiplying all this stuff together, and I'm going to show you that closer to the end. But the point right now is to find out how many options there are at each step. So we're going to go ahead and, you know, clean up a little bit, because I don't want you to think that these are actually out of here at all. So, okay, now we're going to change colors again, because I like colors. And, you know, these 3, not, if I remember correctly, not necessarily distinct. So that tells me that there's kind of an infinite number of each of these things and why. When I hear not necessarily distinct, that means when you pull something out of that set, there's another one of that thing to take its place. It's like getting something out of a vending machine. Even though you got the last, you know, candy bar of your type, even though you purchased one, there's still a candy bar in there. So that means, you know, we've got 1, 2, 3, 4, 5 options here, and, you know, even if I pull out this A, that means I've got 5 options here and 5 options here. So those options don't go away after I use them. So that lets us fill out the slots for the first one, which is if the thing is greater than 30. So that's pretty interesting, I think. Let's go ahead and look at what happens if it's less than 30. So let's go back to the problem, and if it's less than 30, then 4 distinct letters are chosen from Y. So that makes this pretty interesting. So let's go ahead and we've got, whoops, I'm still on purple. We want to go back to the black. If the number is greater, did I get this reversed? I got my signs reversed. And, you know, I always think, oh, the alligator points this way, the alligator points that way, but I always get those things reversed. So this is if the number is greater than 30, and now what we're looking at is if the number is less than 30. Okay. Let's continue. If the number is smaller than 30, then 4 distinct letters are chosen from Y. Well, let's start with the first 2 slots. So it's still going to pull 2 numbers. And again, you know, there's only so many things it could use, and we're going to go to a nice, you know, red so we can see, you know, if this is less than 30, if this is going to be less than 30, then this slot right here is really important. And there's only a couple options. It can't be a 5, it can't be a 6, it can't be a 9. It can only be a 1 or a 2, right? So that means there are 2 options here. But, you know, if we go back up here and look, once you pull one of those out, it doesn't matter what the second digit is, because if it's, you know, 29, say we chose a 20 and a 2 and a 9, that's less than 30. So we can choose any number except for the one that we've already chosen. So that means, again, we've got 4 options here. So hopefully that makes sense. Let's keep on keeping on. So here, if we choose, if it's less than 30, that means we've got 4 distinct things from Y. And so I made 4 slots. That's what you do. You make your slots, and that tells you, you know, okay, I made a slot, that means something's got to go in here. And so we're going to go green, and these are distinct, and that's a really important word. When you see in order or distinct, that means it's not like a vending machine where when you get a candy bar, another candy bar moves forward. This means it's more like, you know, you steal it from, I don't know, you got it out of a Halloween bowl or something like that. Once you pull it out, it's not going back in. So if, you know, if I chose A, that means I can't choose A again. So once you pull something out, it's gone. So at first we have 1, 2, 3, 4, 5 options. So I think we kind of buy that. So let's see. We've got 5 options. So let's say I did pull the A out. Well, I can't use it again. So that means I've got 1, 2, 3, 4 options. Okay, let's say I picked out, you know, and it can be in any order. Let's say I picked out the B, though. I do this for ease of my own mind. So, you know, I pull the B out. That means I can't pull it again, so that means I've got 1, 2, 3 options left. Well, let's say I pull out, you know, let's jump around, because order isn't what I'm showing you here. You know, I'm not saying it necessarily pulls out A, B, C, and then D. So let's say it pulls out E. Well, that means you can't pull it out again. So that means you've got two options here. So that's how you're going to fill out these slots, and this is how you're going to finish the problem. And I think this is kind of the cool part, or at least it's the cool part for me. And I actually just learned this from somebody I was tutoring, and it's a really cool concept, which is ands are multiplication, ors are addition. So ands equal multiplication, or equals addition. So, you know, if I were to do this greater than 30, I'd say that there are 3 and 4 options, and 5 options, and 5 options, and 5 options. And so, you know, if I were to actually read this out, I'd say, you know, the first digit is 1 and the second digit is 2. Oops, this is the greater than 30. So the first digit is 5 and the second digit is 6, and the first letter is B, and the fourth letter, or the second letter, is A, and the third letter is E. So these are all multiplication, and this is one big chunk right here. And so this bit down at the bottom, this is going to be one big chunk, and this is another bunch of ands. 2 options, and 4 options, and 5 options, and 4 options, and 3 options, and 2 options. So, you know, if you can say it in English and kind of pick out your ands and ors, and it's really easy to say extra ands, but, you know, the ors are the ones that really help you, because it could be either less than 30, or it can be greater than 30. And I always get those backwards. It could be greater than 30, or it could be less than 30. And so that means that between these two, there is a big old plus sign. So we're going to add all this stuff together, all the stuff up here, and then we're going to add it to the stuff down here. And that's all we have to do. And so, you know, you can do this math by hand. I kind of cheated and did it beforehand because, you know, I got to be honest, I couldn't do this in my head without writing all of it down. And I think you can do basic multiplication. So this equals 900. Whoops, this actually equals 1500, or 1500. And this equals 960. And here's a trick. When order matters, the number should be smaller than when order doesn't matter. Typically speaking, not always, but it's a pretty good guess that that's what's going to happen. So then we're going to add 1500 to 960, right? Remember, because there's an or. And once you add those together, you get 2460. So 2460, and that is our answer. So let's go ahead and zoom back out and talk about it real quick. So the first thing we did is we're going to go to a nice bright red. We wrote down what we know. We figured out our slots here and here. We figured out what the options were for each, you know, how many different options you had. And we did our ands and our ors, or well, we did our ands, then we did our or, and then we got the answer. So this is a fun problem. It's pretty typical of what you're going to see. So go ahead and do some practice, play around with it, and I think you're going to find it to not be as scary as it may sound at first.